Okay, what I'd like to do today is talk about atomic structure. Okay, this is a bunch of ideas about the atom that you should have learned back in ninth grade, but for whatever reasons you didn't do it or didn't get it, and it's important right now that you do. So I'm going to be explaining some things about atomic structure, especially the information that you saw in the pretest. See if you understand that a little bit better. When we talk about the atom, okay, we understand the atom is broken into subatomic particles. We have things called protons, and we have things called neutrons. These collectively are found in what we call the nucleus. Okay? The other subatomic particle you have is called the electron, and it is found outside the nucleus. Now, protons, neutrons, and electrons are subatomic particles, but they're not the smallest particles. These are actually made up of something called quarks, and electrons are made up of something called leptons. Probably are not going to talk too much about quarks or leptons. Most of our time and energy is about protons and neutrons and electrons. Protons and neutrons are about identifying, at least protons are about identifying the element. If we talk about chemical reactions, it's electrons that are going to be the focus here. Okay, so that just talks about the particles here. If we go and take a look at a symbol, if I have an element symbol and I have, for example, a number 8 up here and a number 3 down here, what does this mean? I mean, what kinds of information can you tell me from this? This is what we call the element symbol. And on the periodic table of elements, this is the collection of all the different element symbols. You can find the element symbol and figure out what the name of the element is. This number here, this is called the atomic mass number. And this number tells you the number of protons plus the number of neutrons that are in the nucleus. Okay? This number down here is the atomic number. This is the mass number, this is the atomic number. And the atomic number is equal to the number of protons in the nucleus. Okay? And, a big and here, since an atom is neutral, that means the number of protons, the number of protons has to equal the number of electrons. Because protons are positive, electrons are negative, the number of positive particles in the nucleus of an atom has to equal the number of negative particles orbiting the nucleus. That makes an atom neutral. When this is not true, we don't call it an atom, we call it an ion. And I'm not sure if that term has been introduced, but if it hasn't, it certainly will be. Okay? Any questions on that? So, here is a quiz question. what if you are given this information? Okay? If you're given this, what can you tell me? Well, maybe the first thing you can tell me that this is an atom of magnesium. Why is it magnesium? Well, it's magnesium because it has 12 protons in the nucleus. That makes it magnesium. If it had a different number of protons in the nucleus, it would be something else. It wouldn't be magnesium. Anything that has 12 protons in the nucleus is magnesium. Second thing you can tell me is the number 12. Well, number 12 is the atomic number. And the fact that it's 12 means to me that there are 12 protons in the nucleus. Oops. Which I think we've already said before. And it means that there are 12 electrons around the nucleus. Okay? And remember, protons are positive, electrons are negative. That means that this atom here is neutral. Third thing it tells me is that 25, this is equal to the atomic mass. Okay? That means the number of protons plus the number of neutrons has to equal 25. And if we already know that we have 12 protons, 12 plus what number is going to be 25? Well, I'm going to have 13 neutrons. You have 12 protons. Why do I put a 0 up there? Because a neutron is no charge. Okay? Are you guys happy? Well, I'm going to stop this and save it, and we'll post it and see if this helps you. If not, bring your questions to your teacher. Thank you.